Alright, section 8-8, volumes of pyramids and cones. Our lesson objectives for this lesson are to use models and a formula to find the volume of a pyramid, and to use models and a formula to find the volume of a cone. Alright, our first term here, or key concept if you will, is theorem 814, volume of a pyramid. And the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So essentially this is telling us that volume is going to be 1/3 times the area of the base. We're still going to be using B. Let me write a better B. B times height. Okay, so that's what we're going to be using. And we're going to be taking a look at a few examples here that make use of this formula. Alright, our first example here is the pyramid is an arena in Memphis, Tennessee. The area of the base of the pyramid is 300,000 square feet. Its height is 321 feet. What is the volume of the pyramid? Alright, so we're going to be using the formula here. Volume equals 1/3 the area of the base times height. In this case, they gave us everything that we need, so all we have to do is plug in the values into the formula and calculate. So that's exactly what we're going to be using, or doing rather. So it's going to be 1/3 times the area of the base, which is 300,000, times the height, and the height is 321 feet. And when we multiply all those numbers, we get that it is 32,100,000, and let me make better zeros, and the units are in feet, and since we're dealing with volume, it's going to be cubed, so it is cubic feet. Let me make a better 3 cubic feet. So it is 32,100,000 cubic feet, the volume of the pyramid in Memphis. And that's what we do for calculating volume of a pyramid. Now let's take a look at an example that you'll get to do yourself. And it states, find the volume of a square pyramid with base edges of 12 inches and a height of 8 inches. Good luck. Alright, on this one, we're still going to be using the volume formula, which is 1/3 the area of the base times height. So I usually work separately, so I calculate the area of the base to the side. So it tells me that the base is a square, right? Because the pyramid is a square pyramid, right? So if it's a square, I know the area of a square is going to be S squared, right? So if I have a square base similar to that, that means that the height is 12 and the width is also 12, right? So we can say that this is going to be 12 squared, and 12 squared is 144, and because B represents area, this is going to be 144 square inches. Then now that we have this, we can plug in the 144 into our formula. So volume is going to be 1/3. Let me rewrite this 3 here. 1/3 times 144 times our height. On our height, they told us it is 8. So we're going to plug in our 8 over there. And when we calculate 1/3 times 144 times 8, we get this to be 384. The units are in inches, so it's going to be cubic inches, and that is the volume for that square pyramid. Okay, moving on to our next example. In our next example, find the volume of a square pyramid with base edge of 40 feet and a slant height of 25 feet. Okay, so let's see how we do this one. Still, we're going to be using the formula that states volume equals 1/3 the area of the base times height. So let's work on the base. So the base, we're still telling us that is a square pyramid, so the area of the base is going to be S squared. And Each edge is going to be 40, so we take 40 and we square it. And 40 squared is 1600. And again, because B represents area and the units are in feet, it is 1600 square feet. Okay? Now for the height. Specifically, they do not tell us what the height is. The height is right over here, as you can see. But it's not specified. They tell us what the slant is. And because the height essentially is an altitude, I can actually bring this out. And we have this little diagram over here, in which the height is right over here. And because h is an altitude, the altitude will bisect my base, which is why it came from 40 and this now becomes 20, right? Half of 40 is 20. The slant is the hypotenuse of this triangle, which it is a right triangle. So to find h, we use the Pythagorean theorem. So Pythagorean theorem states, remember, that the hypotenuse squared equals the sum of the sides squared, h squared plus 20 squared. So let's actually do exactly that. So to calculate h, we say, or we write, 25 squared equals h squared plus 20 squared. Okay, we have that. Then I'm going to solve for h squared. I'm going to just move some numbers around, and we have h squared equals 25 squared. 25 squared is 625. Okay, this 20 squared, to isolate the h squared, I subtracted from both sides, and then I subtract, and 20 squared is 400. Now that we have this, we get that h squared is going to be 225. And to get h by itself, I take the square root of both sides, and the square root of 225 happens to be 15. And the units of this happens to be 15 feet, right? So it's 15 feet. Now that I have the area of the base right here, and now that I have the height, I can go and plug those numbers in. So we have 1/3 times the 1600 times my 15. And when we multiply all those together, we get 8,000. And it's 8,000 cubic feet. All right? And there we have the volume of this pyramid. Okay? Part B is yours. Okay? Find the volume of a square pyramid with base edges 24 meters and slant height 13 meters. Take a look at this one and see if you get the same answer that I do. All right. Again, we have volume, and volume is going to be 1/3 the base times height. So we take a look at the base first. At least that's how I do it. So we're dealing with a square pyramid. That means that the base is a square. So the area of a square is s squared. S squared. So the edges are 24. So it's 24 squared. And 24 squared is 576. 576 area is in meters. Meters squared. Okay. Now we don't have the height. Again, we don't have the height, but we can do the same approach that we did for the first part of this problem, part A, in which we just pulled out a triangle, or a right triangle to be more precise. A right triangle like this. Okay, so our slant happens to be the hypotenuse, so the slant comes over here. The height, or this side over here, is where h goes. And again, this base of this triangle, of this right triangle, happens to be half of the base of the pyramid. So in this case, if this was 24, half of 24 is 12. So this side comes to be 12. And then I will use the Pythagorean theorem because this is a right triangle. And the right triangle, or the Pythagorean theorem, states 13 squared equals h squared plus 12 squared. Now that I have that, I'll rework this equation so it looks like h squared equals 13 squared minus 12 squared. 13 squared is 169 minus 144, right? And that gives me 25. So h squared equals 25. Then I take the square root of both sides and I get that h equals 5. And it's 5, and the units here is meters, so it's 5 meters. Now I have the height, now I have the area of the base, and I can plug all those numbers into our formula. So we have the volume equals 1/3 times the base, or the area of the base rather, 576. We write a better 576. 576 times my 5 over there. And when we multiply all those numbers together, we get 960. The units are in meters, so it's going to be meters cubed or cubic meters. And that's the volume of the pyramid in example B, or part B. Okay? Moving on from pyramids to cones. And we start with theorem 815, which states volume of a cone. The volume of a cone is 1/3 the product of the area of the base and the height of the cone. So what that means is that the volume equals 1/3 the base, the area of the base, times height. The formula is identical. However, because the base of a cone is a circle, that means that the formula that I'm going to be using to calculate the base is going to be the area of a circle. So B is going to be pi r squared. So I can rewrite the volume formula here to state that it is 1/3 times pi r squared times the height. And this formula right here is the one we're going to be using to calculate the volume of a cone. All right? Let's take a look at our first example that uses this. Okay? Example 3, part A states, find the volume of an oblique cone with diameter 30 feet and height 25 feet. Give your answer in terms of pi and round it to the nearest cubic foot. So we have to give the answer in two ways, in terms of pi and round it to the nearest cubic foot. Okay? So let's get started and we'll get there. So the volume again is, I forgot my 1/3, right? Is 1/3 the area of the base times height. So we take the base here and we know that the base is going to be pi r squared. Now we need to find the radius. Do they give us the radius? They did not give us the radius. They gave us the diameter. But we know that the radius equals diameter divided by 2. So we plug in, the diameter is 30. So this becomes 30 divided by 2, which is 15. So we know that the radius is 15 feet. We plug that number in here. Pi 15 squared. And we get that number to be 225 pi. So B is going to be 225 pi. Okay, so now that we have this, we go ahead and plug the numbers that we need. We have the height, so then to the formula it goes 1/3, and we have 225 pi times the height, and the height is 25, and when we multiply all that together, we get 1875 pi, right? 1875 times pi, and the units are in feet, so it's going to be cubic feet. Okay, so this is our answer in terms of pi. It's in terms of pi because pi is part of the number in my answer. Okay, so that's it in terms of pi. Now I need to calculate this in terms or to the nearest cubic foot as the instructions state. So all we're going to do is take the 1875 and multiply it times the actual value of pi. For me, in my class, you guys can use 3.14 as the approximate for pi. Okay, so when we do this, we go ahead and take 1875 and we multiply that times 3.14. And when you multiply that, it comes out to be approximately, and always say approximately because pi is not an exact number. So it is approximately 5,890, and that is cubic feet. Okay, so our solutions are here. In terms of pi, it's 1875 pi, and to the nearest cubic foot, it is 5,890 cubic feet. And that is, for example, 3A. 3B. 3B actually has two problems, right? Two problems, but they're not that difficult, as you can see. And hopefully you'll find them not too difficult, but here they are for you. All right, we have find the volume of each cone in terms of pi and round it as indicated, okay? To the nearest cubic meter for number 1, and the second to the nearest cubic millimeter. All right? Good luck and see if you get the same that I do. All right, for part B, number 1, still we're going to be using volume equals 1/3. 1/3 the base, the area of the base, times height. We know that the area of the base is going to be pi r squared. They do tell us the radius, so we don't have to do anything fancy to get the radius. So we have pi, radius is 6 squared, so the area is going to be 36 pi. Alright, the area is 36 pi, is 36 pi meters, by the way. Okay, so do we know the height? We know the height to be 12, right? It's 12. So we plug in the numbers that we have. 1/3 times the 36 pi. 36 pi times my height, and the height is 12. So we plug in the 12 over here. And when we multiply all those numbers in, we get this to be 144 times pi. And is 144 pi meters or cubic meters. Here, cubic meters there. Now we need to do this to the nearest cubic meter, okay? So we take the 144. We got the first answer, by the way, so here's the first part. And then 144 times 3.14, 3.14 over here. And that gives us approximately 452 cubic meters. All right, and that takes care of the other piece of the problem. So we have in terms of pi, and we have to the nearest cubic meter right over there. And that is part 1. Part 2 is basically the same thing. So we have volume equals 1/3 the area of the base times height, right? So we know that the area of the base is going to be pi r squared, and we have the radius is 21 millimeters, so we have pi 21 squared. 21 squared is 441, so we have 441 pi. Let me rewrite that so it doesn't look, the 1 doesn't mix up with the pi. 441 pi, and we're dealing with area, so it's millimeters squared. Now that we have that, we know the height is 42 millimeters. Plug it in and calculate. So we take 441 pi times our height, which is 42 millimeters, Okay, and when we multiply all that together, this comes out to be, in terms of pi, to be 6,174 times pi. Let me write pi. And the units are millimeters, so it's going to be cubic millimeters. And there we have that in terms of pi, so we have the first portion done. Now to calculate this to the nearest cubic millimeter, we need to multiply this 6,174 times 3.14. So let's do exactly that. Multiply it times 3.14. And that comes out to be approximately, and let me change my sign to approximately 19,396 cubic millimeters. And that's it for this problem in terms of pi and in terms of the nearest cubic millimeter. That's it for this problem. Okay? Now, let's take a look at our last problem for this lesson. Okay? Part A. The covering on a Tepee, which is that tent right there, rests on poles that come together like concurrent lines. The resulting structure approximates a cone. If the Tepee pictured is 12 feet high with a base diameter of 14 feet, estimate its volume. Alright, so let's do this. Again, the formula is 1/3 the area of the base times height. So the base is going to be pi r squared. We do not have the radius. They gave us the diameter. Again, we can say that the radius is d divided by 2, or the diameter divided by 2, which is the 14 divided by 2, which gives me a 7. So I plug in that 7 into my formula for area, and I get pi. I get pi times 7 squared, which is 49 pi. Now that I have 49 pi over here, this is 49 pi, and the units are in feet, so it's going to be 49 pi square feet. I take my base here, or the area of the base, and I plug it in into the formula because I have the height, right? They gave me the height. The height happens to be 12 feet, so it's going to be 1/3 times 49 pi. 49 pi times the 12. And because in here it does not say anything about writing it in terms of pi or rounding it into anything in particular, my answer, I'm going to match it to whatever they gave me, which are whole numbers. The 12 is a whole number, the 14 is a whole number, so I'm going to approximate this to the nearest whole number. So this, when you multiply all together, you get 615.7523, and it keeps on going over there. So this approximates to 616, and the units are in feet, so it is cubic feet. And that is the volume for this Tepee over here. Alright? Now, part B is yours to do. Alright? So it states, a small child's Tepee is 6 feet tall and 7 feet in diameter. Find the volume of the Tepee to the nearest cubic foot. Alright? Give this one some thought and see if you get the same answer. Okay, so the formula has not changed. So we're going to do volume equals 1/3 the area of the base. The area of the base times height. So we take the base to the side, and we know that the base is a circle, so it is pi r squared. So do we have the radius? The radius, again, we don't have. They tell us the diameter, so we know that the radius is the diameter divided by 2. We take 7 divided by 2, and we get 3.5. All right, and that is 3.5. What units? 3.5 feet. Okay, so we go ahead and plug that radius into our formula, and we get pi 3.5 squared. And now that we have that, when we multiply that together, we get 12.25 times pi, and the units are in feet, so it's squared feet for the area of the base. They tell us that the height is 6 feet, so we plug our numbers in, so we have 1/3 times the 12.25 pi times the height, which is 6. Okay, and when you do all those calculations, you get 76 point, let me actually make that better, 76.9690, and it keeps on going that way. All right, and it says to the nearest cubic foot. So the nearest cubic foot over here, this rounds up to approximately 77 cubic feet. And that is the answer for this problem. All right, and that is the end of this lesson. Hopefully it was useful to you. If you have any questions, as usual, please feel free to send me an email or message me on Teams, and I'll be more than happy to help you. Until next time, have a good one.